Just now we have looked at a regular dodecahedron, regular icosahedron. Now let's look at a more complicated case. Now, what is it? This is a soccer. What does a soccer is made of? Not only by a single kind of polygon. Let's have a close-up view. Over here there are several black frames and some white frames. Actually, it contains regular pentagons and also regular hexagons. At this point, let me ask you, how many regular pentagons are there? How many regular hexagons are there? We can use complement angles to explain it. First, we need to analyze how much the inner angle of the regular pentagon. Just now we have calculated the inner angles of regular pentagons are 108 degrees. Similarly, for a regular hexagon, we also calculate its inner angle is 120 degrees. We can look at the vertex. This vertex is connected to a regular pentagon and two regular hexagons. Therefore, the summation of its complement angles 380 minus 108 then minus with 2 times 120, exactly 12 degrees. Since the complement angle is 12 degrees, the summation of the complement angles for all vertices are 720 degrees. 720 degrees divided by the complement angle 12 will get the number of vertices as 60. We then know for a soccer, there are a total of 60 vertices. Each vertex will connect to 3 edges. Each vertex will contain repeatability. Each edge is formed by 2 vertices. Therefore, how many edges does it have? 60 times 3 divided by 2 equal to 90 edges. Whereas each vertex should be corresponding to a regular pentagon. 60 divided by 5 should be 12 pentagons. Each vertex should be corresponding to 2 hexagons. Therefore, 60 is multiplied by 2. The repeatability of hexagon is 6. Then divided by 6 is equal to 20 hexagons. Therefore, we can see that by using the summation of the complement angles, even a complicated structure like a soccer, we can analyze it clearly. In the following session, we will raise an example. If I give you a lot of matches, if you are going to use matches to build a soccer, how many different types of possibilities are there? We want to study how to use matches to build a soccer. Matches should be used as the edges of soccer, but the match has directions, because a match owns a big head and a small head. For this time, there will be 2 directions. It can be placed in 2 different ways. Therefore, we could refer to 2-color coloring of edges. Over here, first we will need to know what is the structure of the soccer. We have calculated the soccer has a total of 60 vertices, 90 edges, 12 pentagons, 20 hexagons. With these parameters, let's analyze its permutation. First, there is no movement. It is performing 2-color colorings for the edge. There are a total of 90 edges, no movement. There are 91 outer cycles. Of course, the soccer could be rotated. Over here, we can see that for pentagon, 2 opposing pentagons are facing each other. Therefore, it can use the face centers of 2 pentagons, rotate around the face center of the pentagons. How many angles can it be rotated? The edge of the pentagons correspond to the inner angles. 360 divided by 5 is 72 degrees. It can rotate 72 degrees, or maybe 2 72 degrees, or maybe 3 72 degrees, 4 72 degrees. Therefore, this kind of rotations compose several permutations. How many is this kind of pairs of face centers of 2 opposing pentagons? There are 12 regular pentagons. Each 2 opposing pentagons could have a pair of face centers. There are a total of 6 face center rotations, whereas for each rotation we will realize the 5 edges of the regular pentagons compose a cycle. Therefore, it is a 5-order cycle. Since 5 edges are forming a group, then how many edges are there in total? There are 90 edges in total. Not only the edges of pentagons are having cycles. Similarly, for all the edges which connecting to them will compose corresponding 5-order cycles. 90 divided by 5, there are total 16 5-order cycles. For this kind of face center to face center rotation, how many different permutations should it be there? First, there are 4 angles, whereas there are 6 different symmetry axes. Therefore, in total, there are 24. For hexagon, white hexagon and the opposite white hexagon may also structure a face center to face center. Each time, it should rotate 2 grids. We will realize if I rotate 1 grid, the white will be turned into the black portion. It will not have the coincided image. Therefore, its rotation degree should be 120 degree. For 120 degree in total, there are 2 different angles. Whereas, how many pairs of this kind of face centers? Because there are 20 hexagons. Therefore, it contains 10 this kind of center face pairs. For each rotation, it could be 3 edges form a group. How many groups are there? 90 divided by 3. Whereas, how many this kind of permutation are there? It should be 2 angle degree multiplied by 10 face center. In total, there are 20. In the following, except this, we will realize actually hexagon and hexagon, its edge center is constantly the edge center of the opposite ones. It was then an angle which can be rotated. Therefore, there is another permutation. Is the center point of the edge of the hexagon as axis and rotated with 180 degree. Then, how many in total are there? This kind of rotation method, actually we need to analyze that how many hexagons there? There are 20 hexagons, where each hexagon contains 3 kind of edges which can perform the flipping. Its number should be 20 times 3. This edge is commonly used by 2 hexagons, therefore need to be divided by 2. Whereas each 2 edge corresponding contains an axis, therefore divided by 2 again. Its answer is 20 multiplied by 3 divided by 2 divided by 2. In total, there are 15 pairs. May be used as an axis to perform the flipping. And this time we will realize if there is one matrix which placed over here, once it was flipped, it will have another look. It will become the big head is heading down. Then let me ask you, does it exist a fixed point? Because the flipping of edge does not contain any fixed point. It is a situation which contains no fixed image. Of course, we can still write the corresponding permutation. If over here, this is the angle of the edge, this edge can actually be seen as the fixed edge. The remaining ones happen to be 2 by 2 edges. The exchange of 180 degree. Therefore, one order cycle may need 2. 2 order cycles contains 44. In total, there are 15 pairs of this kind of operations. We write out all the permutations substituted into the polyhedron, which is 2 colors coloring, which is 2 to the power of 90, added up with 24 times 2 to the power of 18, added up with the 20 multiplied by 2 to the power of 30. Lastly, there is one no fixed image. If there is no fixed point, it does not need to be calculated. Therefore, we only need 290 added up with 24 multiplied by 2 to the power of 18 added up with 20 multiplied by 2 to the power of 30 divided by all the number of permutations. The number of permutations exactly 1 added up with 24 add 20 add 15 exactly equal to 60. This is all the solution number of using matches to build a soccer. In the following, let's raise an example. Similarly, it is still a dice. We do not look at the individual dice. We use the same dice and stack it into a regular hexahedron. What does it mean? Dice itself is a square shape. Then, in the following section, it contains different rotation method and positioning method. If take several dices and accumulate them orderly over its last row, I can use 8 dices to form a regular hexahedron. So this kind of dice placing method contains how many different possibilities? First, we need to look at the question or conclude it as a rotation group of a regular hexahedron. Performing rotation over a regular hexahedron, we are very familiar to it already. It contains a total of 24 different rotations, whereas each dice is actually labeled with the corresponding positions which supposed to be which kind of the position method. Because each dice may consider as occupying a vertex, it is equivalent to color a vertex with 24 coloring. Why is it 24 coloring? Because over this dice, there are 24 different types of rotation method. Therefore, for all the corresponding permutation group of regular hexahedron are all written out. After writing them all out, we actually may directly apply polyhedron will do. But once we look back and think we must be very careful, we need to think, is there any fixed point? Is there any fixed image? And this time, we will be thinking that what is the structure of a dice? Each face of the dice correspondingly contain a different point value. For a fixed point, it can completely structure out a corresponding fixed image. For face center to face center of 90-degree rotation, let's think about it. Face center to face center rotated 90 degrees, such a rotation still manages to guarantee it will remain the original looking. For face center to face center rotated of 108 degrees, it can also be the same. But for one part is that those which we can't get a fixed image, we can take a look at the vertex. Its faces 1, 2, 3, and so on. If we follow this vertex and then corresponding vertex to perform 120 degrees of rotation, we'll realize that this face is changed to another face. After it was changed, the point on top of the face may not be the same, cannot guarantee that it has a fixed image. Therefore, at this time, it actually corresponding to diagonal lines as axis. When it is rotating positive or negative 120 degrees, it has no fixed image. Because it does not exist a fixed point over here, we do not need to consider it. Similarly, we will realize under other circumstances, if it can structure a fixed point, its number should be towards 24 coloring. 24 coloring, the first one order cycle is 8. Therefore, it is 24 to the power of 8. Add up with the 6 times 24 square. Add up with the 3 multiplied by 24 to the power of 4. Add up with 6 multiplied by 24 to the power of 4. The last one contains no fixed image. Because this equation divided by 24 may obtain the same dice stack. How many different solutions for regular polygon?